Hi, everyone. Um, I'm Nick Rout. I'm an Android Developer Relations Engineer at Google, and you can follow me on most places at Rick Naut. Um, and today I'm going to be talking about custom design systems in Jetpack Compose. So for those of you who might have been doing Android development for a while and dealing with Google products as a whole, you'll know perhaps that Material Design is Google's recommended design system. But in the real world, what tends to happen is that folks tend to have either a sort of like customized version of Material Design, like the design team will build on top of it, or you'll have a completely independent design system from Material. And this is actually fine. You don't have to use Material Design, and also you don't have to use the library implementations that Google ships in both Android views and Jetpack Compose for these. You can go ahead and implement your own design system and use the lower level APIs to do this yourself. So that's actually what we're going to take a look at today and do a bit of a deep dive into how you can go about doing this and what, basically, first of all, like look at how material theming works in a very, very brief nutshell, and then more go into like the anatomy of how that works under the hood, because there's quite a lot of abstractions on top of that. And then go into 3 different approaches for how you can do custom design systems to varying degrees of complexity. So things like extending material theming, so using material theming but building on top of it, replacing material systems, so taking out one of the things like color theming in material design and replacing it with your own implementation, or implementing a fully custom design system where you don't use material design at all and instead build it from scratch yourself. We'll then also take a brief look at how you might use a custom design system but still end up using the material components, things like buttons, radio buttons, chips, etc., with a custom design system. So let's start off by looking at material theming. This is sort of the easier way, or the entry-level approach to theming with Jetpack Compose. So we'll start off by taking a look at 2 variations of material design. If you haven't heard, material design is now split into 2 versions because there was Material U introduced with Android 12. So we basically have Material Design 2 and Material Design 3, and they both come with their own Jetpack Compose library. Starting with Material Design 2, which is the more mature library right now, you can implement a material theme by using the material theme composable, pass it colors, typography, and shapes. These are the 3 systems of material theming, which the material components and other parts of your app will use in a theming way. With Material Design 3 / Material U, it's very similar. In fact, the composable name is exactly the same, except the parameters are slightly different. There isn't any shape theming at the moment, but you do pass through a color scheme and typography. If you want to learn more about material theming in Jetpack Compose, there is a link in the slides and there's documentation on developer.android.com. But that's not the topic of today's presentation, so I'm going to be very brief in this regard and then jump straight into, okay, cool. So this is a material theme, but how does it actually work under the hood? First, I also just want to point out that you can then access material theming values in your app if you set up either a Material Design 2 or Material Design 3 theme by using this dot notation, material theme.colorscheme.primary, for example, or material theme.typography.body small. That's how you like get the theming values once you've actually wrapped your app in a material theme. Then you can use it in something like a text composable and change its color and text style to be something like your primary color and the body small text style. Just a very brief, simple example. So now I want to take a look at how this actually works under the hood. We've seen the sort of high-level abstraction of how you wrap your app in a material theme and how you access those theming values if you want to use them in your app. But how does that all really work? So by inspecting the source code of material theme, we can see that this is just a composable function. It's no surprise that it accepts the parameters that we've seen before that we'll pass to it in our app, things like color scheme and typography. And then this third parameter, which is a content parameter. We'll take a look at each of these and just see what they are. Starting off with the color scheme and typography. What these are actually just classes, Kotlin classes that model a particular material system, a theming system, if you will, which is like effectively a way of grouping together values that are in a familiar family. So in this case, we've got a bunch of colors. You can see on the right illustration of what these colors sort of represent, but this class holds all of these values, things like your primary color, on primary color, primary container, etc. The same can be said for the for typography. It's just a class that that has a bunch of values and is strictly typed, so to speak, and accepts parameters like body small, body large, etc. to model again the material design typography system. The third parameter is this content parameter, which is actually allows you to nest, have a trailing lambda to nest your app content. So all that really allows you to do is basically provide a material theme and then have a trailing lambda in which your app content goes, basically just other composables that become themed by this material theme. But the interesting stuff of how this all works actually happens inside this function. The parameters we've seen, we probably would have dealt with by using a material theme in our app, but what actually happens inside this function? And again, we have to look to the source code for this. And although this is a slightly simplified version, the main part of this is something that you see here, which is called a composition local provider. And then a bunch of the values passed in, which are a local color scheme, which provides color scheme, a local typography, which provides typography, and the content which we saw before, which we passed through to this composition local provider. So we're going to dig into a bit of that and see what all of this means. We're going to start off with the composition local provider. For that, we need to actually just talk a little bit about something called locally scoped data in Jetpack Compose. So a composition local is basically a tool for passing data down through a composition implicitly. Effectively, this like tree of composable functions that forms your UI. So usually in Compose, like data flows down through the UI tree as parameters to each composable function. So sometimes what you have to do is like pass through a value to multiple functions that are nested to each other. And this makes these dependencies explicit. However, this can sometimes be cumbersome for data that is very frequently and widely used, such as colors and type styles. You can imagine basically like if you didn't have a theming system in place, you might have to pass through a color all the way up from your like top level app composable down to the UI that then uses it. So there might be like multiple levels deep in a button, then finally has to use a color and a type style, which can really bloat your code quite a bit. So to support not needing to pass values as explicit parameters to most composables, this is where composition local comes in. It allows you to basically create tree-scoped named objects that can be used in an implicit way to have data flow through the UI tree. So it's effectively like an omnipresent parameter that you don't have to pass through to each function. Now that we've had a look at some of the theory, we can see here that what we have is this something called a composition local provider, which provides composition locals down the UI tree for Jetpack Compose. In our case, it's these two things here, local color scheme, which provides the color scheme, which is a parameter to material theme, and local typography, which provides typography. Let's take a look at those. So all these are really are instances of composition locals. We create them with this static composition local of, which is a function that creates a composition local and pass it a default value. And this is all it really is. These are composition locals that model both the color scheme and typography classes and provide them implicitly down the UI tree. So when you actually want to access the value of a composition local, you'd normally do it like this. So you'd say local color scheme dot current dot primary or local typography dot current dot body small. This would happen inside your app within the theme. So then how does this work? Why does material theme have this special notation where you say something like material theme dot color scheme dot primary, and like how did material theme get this sort of special use case? Well, as it turns out, it's not that special. All it really is a nicer way and a more idiomatic way, perhaps, to access theming values. And if we have a look at the source code again, we can see that what the Compose material developers have done is that they've instead created an object which is named the same as our function material theme. So we have an object material theme. And within those, they create a value and then override the getter to be local color scheme.current. So that's this notation that you see here. Really, all it is just a wrapper over that normal way to access the current value of a composition local. And this allows us to do the sort of nice material theme dot color scheme dot primary, so you know what you're getting and what theming values you're trying to get. Same can be said for the typography object. It's just another, the typography value, which is just another value in this object, which allows us to get the composition local for typography. So in a nutshell, let's take a look at the anatomy of a theme in Compose, using the example of a material theme as our case study. So here we've got four things. We've effectively got theme system classes. An example from Material 3's theme is a color scheme, but then we have other things like typography, other things like shapes. These are just classes that model a system of a design system, basically a subsystem of a design system. We've then got composition locals that are used to provide these systems to all parts of your Compose work. So in our case, an example would be local color scheme. We then have a theme function, which wraps all of this together. So the theme function then uses composition local provider to provide something like the color scheme. Lastly, we have this convenience accessor, an object which is named the same as our theme, which just allows us to do something like theme.colors.primary. So these four things are sort of the pillars of what a theme is in Jetpack Compose. And knowing that, we can actually use that knowledge, which is all freely available and visible and open source, by the way, to extend material theming and basically create custom design systems for ourselves. So let's start by looking at a simple use case or simpler use case of extending material theming. So Compose material closely models material theming. It's a design specification that lives on material.io, and it's effectively like a Kotlin implementation of that, and it makes it simple and type safe to follow material guidelines. But it is possible to extend the color, typography, and shape sets with additional values, and this tends to be a fairly common use case in my experience in companies that use material design. The first and most simplest way that we could potentially do this is actually to use Kotlin extension properties. We don't even have to go into the whole composition locals and the approach that material theme takes. We can do this for something like, we can basically take that colors class, which is that system class, or the typography class, and create extension properties on top of those, which then allow us to access those in the same way that we would do our normal material theming values. So something like a snack bar action color or a text field input color. A word of caution here, though, that this approach is only really recommended for simple theming value additions or for values that are the same in different themes. If you happen to have two implementations of a material theme in your app, perhaps like for a subsection of your UI or for a different screen, by creating an extension property, it's going to be the same regardless of the theme. So you need to keep that in mind. Then if you have multiple themes, it's actually better to define a new class with new properties instead, which is what we're going to dive into next. So let's create an extended theme rather. Let's go slightly deeper, dive a bit deeper, and actually bolt on more theming values onto the material theme in the same way that it implements its theme under the hood in Compose. And our use case here, or our example here, is to add 2 additional colors to the material theme color palette, tertiary and untertiary, which don't exist in the baseline values. But we still want to keep the existing material colors and all the other material things that that come with the baseline implementation. So first, we need to start by creating a new class. Here, I've used a data class called extended colors, and I've added 2 colors to it, just tertiary and untertiary. You'll see that they use the color class, which is part of Compose's foundation. And you'll notice there's an annotation there called immutable, which is effectively a signal to the Compose compiler of how to like retain or not retain this class. There's a bit more detail around that in the documentation, and I won't go into it too much right now, but it is there is links to that in the docs on developer.android.com, again linked in the slide. So we've made a simple data class with two values, tertiary and non-tertiary. We then need to create a composition local of that. So we're again using static composition local of, passing it an extended colors instance, which is just going to be our default values. And then here we're just using color but unspecified as our defaults because we don't want to assume any particular defaults for extended colors implementation. We then create our theme function, which I've named extended theme. And the initial parameters for this are going to be all the things that you would expect to pass to a material theme, because remember that we want to keep all the material theming values. Our additional extended colors parameter, which is going to model our extended colors, and then our content parameter. We then use, in the same way that material theme does, composition local provider, and then we use that composition local extended colors to provide our extended colors, which is passed through as a parameter to our function. And within that, we still need to call material theme because we do want to actually provide all the other material values like colors, typography, and shapes, and pass those values through to it, as well as our contents parameter. Lastly, we need to create that object, which allows us to grab the extended colors in a more convenient way. So here I've created an object, it's the same name as my theme, provided a colors value, and then just use the getter to have local extended colors.current. And then what you end up with is something like this. So when we actually want to use this extended theme, we will create an extended colors instance, and we pass through some colors that you can see on the right, which the designer has provided. We then actually call the extended theme function and pass through the extended colors value that we've created. And then we can start using it in our app in any normal, and in the same way that we would do material theme dot colors, we can now do extended theme dot extended colors. So that was a look at extending material theming with additional values. What happens if you want to actually replace one of the material systems? It's like colors, typography, or shapes, and like remove one of them or put a different one in, and basically like rejig some of the actual core systems of material design, but keep some of them in place. So instead of extending material theming, you may wish to replace like one or more of these systems with a custom implementation, but you may want to maintain the others. So the example we've got here is that we want to keep the color system, so all the material colors, but we actually don't want to use the material typography system or shape system. We want to get rid of those and instead provide our own implementations of typography and shapes. How do we do that? So firstly, we're going to actually follow a very similar approach to what we did for extending the theme. In fact, you'll see this throughout, that there's a very standard approach to doing this. So I've again made a data class for replacement typography using that diagram on the right that I got from the designer to model this class. And the same can be said for replacement shapes. We create two composition locals of these, again passing in some defaults. So in our case, it's going to be replacement shapes and replacement typography. We create this replacement theme function again, and you'll notice here that the parameters only accept the material colors parameter. There's no material typography or material shapes. Instead, we pass through our own implementations of these, as well as the content parameter. We then use composition local provider again to provide our local replacement typography and replacement shapes. And then we still need to, again, use material theme because we want to maintain the material colors and pass through that colors object to this material theme, as well as our contents. Lastly, we create this object again to help us with like this convenience access object for our replacement typography and shapes. And then how does this look in practice? So say we want to actually do the implementation on the right with our certain title style and body style and component and surface shapes. I've made two example implementations here where I've instantiated a replacement typography and replacement shapes. I've passed this through to a replacement theme. I'm calling that function, as well as the colors that I would have gotten from somewhere else and instantiated for the material theme. Then our app content can begin using these theming values with replacement theme, dot replacement typography, or dot replacement shapes. Lastly, I want to take a look at implementing a fully custom design system. So that's going to be effectively replace material theming altogether with your own fully custom design system. So a design system in theory is not limited to the concepts material relies on. It's really just a way of grouping together these systems that model a particular reusable thing that the components of your app will use. So you can actually modify existing systems or take inspiration from the material ones or introduce entirely new ones that aren't in material, that aren't typically themable, with new classes and types to basically make themes compatible with another system that you or your team or your design team can envision. So here we've got a custom theme, which doesn't use any material values at all. It's got a colors system, and it's got a typography system, and it's got an elevation system. So our colors look quite similar to the material ones, but instead we've actually got a gradient, which is modeled by a list of colors. Our typography is quite similar to material, but it's only got 2 values, and elevation, which is actually not part of the normal material theme, is something that we're modeling for a default state and a press state, which we could then provide to components to say, yeah, this is your elevation when in normal state, and this is your elevation in press state. So we're going to actually follow, again, really similar to what we've seen before, creating data classes of our custom colors using the relevant types, our custom typography, and our custom elevation. These are all types that are provided by Compose Foundation, by the way, things like color or list of colors or textile or DP, which models like elevation. We then need to create our composition locals once again. So here's one for our custom colors and using relevant default values. Here's our custom typography. And lastly, here's our custom elevation. You'll notice that Compose has all of these like basically unspecified or default or empty values, which I would recommend using in these instances, because a default value of a composition local should not really assume or be opinionated about what the value of like a color is or a gradient or a textile. We then create our custom theme function. So in this case, we're not accepting any parameters that come from material. We've just got our custom colors, custom typography, and custom elevation, and our content. We again use composition local provider, providing our custom colors, custom typography, and custom elevation. And actually here, this is where it stops. At this stage, we don't have to call material theme because we aren't using any of the values from it, and we wanted to create our own entirely custom design system. We then just pass through the content rather to the composition local provider directly. To make accessing these values simpler, again, we use an object called custom theme and have values like colors, typography, and elevation, which have the types of all of our custom classes that we've created. Using it is, again, very simple and very similar to what you've seen before. We create instances of custom colors, custom typography, and custom elevation, which you can see on the diagram on the right. We then pass that through to the custom theme, calling this function, and then our app can start using our custom theme values by things like custom theme.custom colors, custom typography, and custom elevation. The last topic I want to touch on is using material components in a world where you've implemented a custom design system in this way. While you may want to tweak your theme and maybe even entirely replace material theme to provide different themable values or extend on top of material, you may still wish to actually use the pre-built material components, things like buttons, things like chips, cards, etc. These components are actually built to have their default values come from material theme. So if you were to use them in a case where, let's say, use a fully custom design system, their defaults are going to be kind of strange. They're not going to be able to find the theming values, and they may not work as you expect out of the box. So you need to do a bit of workarounds here, depending on the extent of your custom design system. So firstly, if you're using an extended theme, you're going to want to have this approach, which I'm going to call wrapping a material component. What this is doing is like having a function which is wrapping the existing material composable function that provides it with the values from your custom theme. So here, in this case, we set it up by effectively just creating a composable function called extended button and passing through all the sort of like standard parameters and on click listener, a modifier, and content. We can then introduce like additional values here. So over and above the standard parameters that allow us to theme our button with values from our custom extended theme. So in this case, with the button, we override its default to rather use colors from our extended theme as opposed to colors from material theme. And what this is going to do is that mean that we can have a button that uses that tertiary or on-tertiary color for the button and its label or icon in a way that wasn't possible before. If you're replacing a material system, you need to take a slightly different approach. So you need to make sure that because now that you've removed one of the material systems, and most material components will use aspects of colors, typography, or shape, you need to make sure that there's at least a reasonable default in there, or that it's coming from your replacement theme, so that the components behave as you would expect. Again, we do this basic setup of having these sort of like standard parameters and then passing those through to the button. You'll notice here that we don't pass through the content, and that's for a good reason. The reason for that is that because our content is where text styles tend to be used, we need to wrap our content in another function that provides our replacement themes typography to any label, which would be in the form of a text composable within it. We also then override the shape parameter to come from our replacement theme. And what this is going to do is just mean that our shape theming values and our typography theming values are going to be used in this button over and above the material theme ones. But importantly, because we've maintained the material theming color system, those colors will still be in place. Lastly, if you're using a fully custom theme, i.e. there's no material theme present, using material components as is will basically result in unwanted colors, types, and shape values all over the place, because they're just going to be having sort of like unspecified values in place, which Compose tends to interpret as something like just black or white or whatever makes reasonable sense. So if you want to wrap a button for a fully custom theme, again, setup is providing standard parameters and passing those through to the button. But you then need to actually override quite a few values here. So in this case, our button relies on the material theming system, so you need to provide colors to it. Usually you have to override most of the colors in this button colors object, so things like our background color and content color, but also things like our disabled background color and disabled content color, because sometimes we'd leave those to come from the material theme, but in this case, there's no material theme whatsoever. We need to do the same for shape. And in this case, because our design system, our custom design system, actually has no concept of a shape system, which you'll see in the diagram on the right, we will have to either hard code those in place using the foundation functions like rounded corner shape or cut corner shape, or potentially just abstract that to a value somewhere that can be used. And we can then also override its elevation, which is something that the button composable does accept, with values from our new custom theme, which actually wasn't possible with material theme before, which is pretty cool. And that is about it. That's all I have for you today. I see there's a bunch of comments in the chats, and I really appreciate that. So I'm going to maybe take a look and see if anyone has any questions. But for now, that's all I have to show you.
Oh, very nice, man. Very nice, very nice. I'm actually very excited to implement everything that you actually discussed today. I'm just excited. You know, Compose just gets me really really excited. Yeah. So we actually have a question. So if we're creating a Compose theme in an existing view-based app by using MDC theme, how can we still have custom colors in the XML theme and make them available in the MDC theme?
It's a very good question. For those of you who don't know, there's a separate small library that I actually maintain called MDC Android Compose Theme Adapter. What that does is like, it's a composable that extracts like theming values from a context in a view-based app and makes them available in Compose. And yeah, I can drop a link, or actually I can find a link to that and drop it in the chat if you're not familiar with it. But at this point in time, it's actually not set up to handle custom theming values that come from your XML theme to make them available in Compose. With that being said, it is something that I'm aware of. It is a feature request that I'm strongly considering, and I would say watch the space. But right now, when you use that, you're kind of stuck with the main like material theming, or the vanilla material theme composable. However, with that being said, now that I'm thinking about it, oh wait, no, that wouldn't work. But you could do something like extend that, like with the first approach that I showed in these slides, but it would end up lead to some recreation of like what you did in XML. So it's kind of besides the point. But good question, good feature request. It's on the to-do list.